Hello, welcome back to 5th grade Green Math. I'm Linwood Fields, your Green instructor. This is Lecture 14, which is on Fractions 101. So we are going to be covering the basics of fractions. The objectives. Once you finish this lecture, you should know what a fraction is, be able to identify the numerator of a fraction, be able to identify the denominator of a fraction, and know how to write a fraction from a problem statement. Okay, what is a fraction in the first place? A fraction is just a ratio of the number of objects selected to the total number of objects. So the key in this definition is we have two parts of a fraction. We have a total number of objects, and we have a certain number of that total that we select. Fractions use division notation to represent numbers less than 1. Think of a fraction as a piece, not the whole selection, but just a piece of the selection, or not the whole amount, but just part of the total. For example, 3 divided by 4 is a fraction. According to this definition up here, 3 is the number of objects selected. And according to this definition, 4 is the total number of objects. So 4 is the total number of objects that we can possibly select. And in this particular fraction, we actually selected 3 of that 4. Yes, you are correct. 3/4 is the same as 3 divided by 4. Okay, so let's just show you another example of a fraction. Let's say we have a yummy pizza, and we divide this pizza up into 4 equal parts. Okay, we got 1, 2, 3, 4 parts. So if we were to select one of the pieces of, let's select one of the pieces of pizza. So let's select this part right here, or this piece here. So we see that we have 1, 2, 3, 4 pieces. That's the number of total pieces. And we've selected one of those 4 pieces. So let's represent this situation with a fraction. Okay, so yes, the total number of pieces is the denominator, or the bottom part, which is 4, and the number of pieces that we selected is 1. So this fraction here is 1/4. Okay, let's dissect a fraction. That means that I'm going to show you what we call the different parts of a fraction. We're going to consider again the fraction 3/4 that we saw in the previous slide. Okay, we have to get used to the notation used to describe fractions. 3 is called the numerator. So 3 is the number above this horizontal bar. In division, 3 is known as the dividend. 4 is called the denominator. The denominator is the number below the horizontal bar. In division, 4 is known as the divisor. So the numerator is the number above the horizontal bar. The denominator is the number below the horizontal bar. Okay, let's show how fractions and division are basically the same thing. What we have here on the left is the fraction 3/4. This same notation in division is called 3 divided by 4. They look the same, they are the same. In fraction language, the number above the horizontal bar, the 3, is called the numerator. In division language, the number above the horizontal bar, the 3, is called the dividend. In fraction language, the number below the horizontal bar, the 4, is called the denominator. In division language, the number 4 below the horizontal bar is called the divisor. So that's why I introduced you to division before fractions, because you need to understand division in order to be good at fractions. Think of a fraction as a group of objects where we want to select a certain number of objects, or a certain number of the objects. The denominator is the total number of objects that we can possibly select. And the numerator is the number of objects that we actually select. Therefore, a fraction is just a ratio of the number of objects that we select to the total number of objects possible. So that's basically what a fraction is, no more, no less. Let's look at a green example. We have already been introduced to the solar panel, which is a group of solar modules. Solar modules are used to make clean electricity. They are cool also. Solar modules convert the sun's renewable energy into electricity, and it does so without polluting the environment. Okay, let's assume that my solar panel has 10 modules and that 3 of the modules are shaded early in the morning. The fact that they are shaded means that they are not producing electricity because they need to have the sunlight in order to produce the electricity. So we're going to represent this situation with a fraction. Okay, and here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 modules. The unshaded modules are the ones that are not shaded in with green. The shaded modules are these 3 here that are shaded in with green. Here's the problem that we want to solve. We want to know what fraction or ratio of the modules are shaded? Okay, so we already know that our fraction has two parts, a numerator and a denominator. Remember, the denominator is the total number of parts. So we see that we have 10 total modules. Now, how many of those are selected? In this case, selected means shaded. We see that we have 1, 2, 3 modules that have been shaded. So the answer is 3/10. 3 out of 10 have been shaded. That's this answer right here, 3/10. So notice what we have done. We have taken a problem statement and produced a solution. And that's very important to do. And in fractions, basically what you have to do is, in order to produce your solution, you have to be able to correctly identify the denominator, which is the total number of parts here, 10, and you have to be able to identify the numerator, which is the number of objects that we select here, 3. And question 2, what fraction or ratio of the modules are producing electricity? Remember, the ones that are producing electricity are the ones that are not shaded. So let's erase the first answer. Okay, so again, the denominator is the same. The total number of modules is still 10. This time, we want to select the number that are not shaded, or the number that is not shaded. We see that we have 1, 2, 3, 4, 5, 6, 7 modules that are not shaded. So the answer is 7 out of 10 modules are producing electricity. And that is this answer right here. Okay, we're going to look at another example, and we're going to emphasize again that fractions are ratios. And what we're asked to do is we're asked to arrange the ratio of area values for this rainbow of circles. We want to arrange the ratio values in this table here. We want to arrange those in order from smallest to largest. These ratios are fractions. So all of these are the ratio values, and all of these values are these ratios are fractions, where the purple circle represents the total amount of area available, and the area of the other circles is the amount of purple area that is selected, or the amount of the purple area that is covered up by the different colors. So we see that the blue circle covers up a certain part of the purple circle. The green circle covers up part of the blue and the purple circle, but we're only interested in how much the green area would cover up, assuming that all the other circles were not there. And the same with each circle that's not purple. We're interested in how much area that circle would cover up if it was placed on top of the purple circle. And that ratio of areas is these values here that we have in this column here. Okay, so let's go ahead and let me draw a picture where I show the same amount of area, but I'm going to draw it in a different way. So let me go ahead and draw my 6 circles. Oh, Okay, I want that to be in purple. One, two, three, 4, 5, 6. So I drew these in purple because the purple circle represents the largest area. That's the area that is representing the total amount of area. Okay, now in the first case here, the purple circle area to the purple circle area ratio is 1. Remember, the purple circle represents the total area, and that's the denominator. So the denominator represents the total number of parts. So in this case, the total number of parts is 1, and the numerator represents how much or how many parts of the total number of parts we select. Well, in this case, we're going to select all of the purple area. So we're going to select one piece, but we only have one piece. So the 1 over 1 is the ratio of purple area to purple area. Now let's go over here to the next entry, the blue circle area to purple circle area. And we're saying that that ratio is 3/4. So I'm going to draw it in a different fashion than what's represented up here. So first of all, I'm going to divide my circle into 4 pieces. 1, 2, 3, 4 pieces. And if we look at the fraction says that the numerator is 3. So that means that we have selected 3 parts. So let me go ahead and select 3 parts or 3 pieces of the circle. 1, 2, 3. So the 3 is the number selected. That's the numerator. And the denominator is the number of pieces we divided the circle into. There are 4 total pieces. Okay, let's move over to the next entry. The green circle area to purple circle area is 1/2. So we recognize the 2 as the denominator, and we recognize that 1 is the numerator. So let's see what that looks like in this picture here. We're going to divide the circle up into 2 parts because the denominator is 2. So we see that we have 1, 2 parts. Now the numerator 1 tells me to select 1 of the total number of parts, select 1 of the 2 parts. Okay, so I'm going to select the rightmost part. Okay, and that is 1/2. So the fraction 1 over 2 is 1/2. Okay, let's move to the next entry, the yellow circle area to purple circle area. We see that the denominator is 3 and the numerator is 1. So we know that we're going to have 3 pieces total. So we're going to divide the circle up into 3 pieces, and we're going to select 1 of those 3 pieces because 1 is the numerator. So let's see if I can divide this circle up into 3 pieces. Okay, there are my three pieces. 1, 2, 3. And I need to select one of those pieces. So I'm going to select this piece here. Okay, that's 1/3. Okay. My next entry is the orange circle area to purple circle area. Now remember, in each one of these cases, the purple circle represents the whole amount. So the purple circle represents the denominator in each case. Okay, so for this entry here, for the orange circle, the denominator is 4. Just like in the case over here for the blue circle, the denominator was 4, meaning that I'm going to divide the circle up into 4 parts. But in this case, unlike the case for the blue circle, where I selected 3 parts, for the orange circle, I only select 1 part. So my numerator is 1. So let's color in 1/4. Okay, and now for the last case, the red circle area to purple circle area, that's 1/10 or 1/10. So my denominator is 10. That's the total number of parts I'm going to divide the circle into, and the numerator is 1. So that's going to be how many parts I select. Now dividing this circle up into 10 parts is a little bit trickier, so bear with me. I'm going to do the best that I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, those are the 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to select one of those pieces. So I'm going to select this piece right here. And that represents 1/10. So basically, even though the shapes are different in these 6 different cases down here, it still is representing the situation up here, where up here, this red circle represents 1/10 of the total, just like this red piece here represents 1/10 of the total. Okay, and so the question was, arrange the ratio areas in order from smallest to largest. If I look at this table here, they are already arranged in order, but they are arranged from largest to smallest. So we see that this is larger than this purple, this shaded area is larger than this shaded area. And these 3 pieces of blue is larger than this 1/2 of shaded green, which is larger than this 1/3 of yellow, which is larger than this 1/4 of orange, which is larger than this 1/10 of green. So let me go ahead and answer the question. Rearrange the ratios in order from smallest to largest. The smallest is 1/10. The next smallest is 1/4. And then the next smallest is 1/3. And then the next smallest is 1/2. And then the next smallest is 3/4. And the largest is 1/1. So notice that when the fractions all have the same numerator, in this case, let me cross out this fraction here because it's not relevant for the point that I'm getting ready to make, because it has a numerator of 3. Now, all the rest of the fractions have a numerator of 1. A numerator of 1. So notice, when fractions have the same numerator, the denominator with the largest denominator is the smallest fraction. So because 10 is larger than the other denominators, 1/10 is the smallest fraction. Because the denominator of 1 is smaller than all the other denominators, then the fraction 1 over 1 is the largest fraction. Again, when fractions have the same numerator, then the fraction with the largest denominator is the smallest fraction. So let me go ahead and erase all of this. Okay, so we've already looked at the area of the blue circle. It's only 3/4 the area of the purple circle. And all the way down to the red circle is 1/10 as large as the purple circle. And the answer is the ratios from smallest to largest. We've already done that: 1/10, then 1/4, 1/3, 1/2, 3/4, and 1. So basically just rearranging or reversing the order of the values that's listed in this column. Summary: a fraction is a ratio of the number of objects selected to the total number of objects. Fractions use division notation to represent numbers less than 1. The numerator is the number above the horizontal bar. Now, forgive me here, horizontal is not spelled correctly. It should be a T in here between the N and the A. The denominator is the number below the horizontal bar. Thanks for attending Lecture 14. I hope to see you at Lecture 15. We're going to pick up with fractions again. Have a great evening.